So today we are at the last domain, which is software development security. Very simple. You do not need to know. You need to understand the security my issues once you are either buying software, you are making software, or you're involved in some kind of software activity. Okay, that is the main motive. After 10 years of working in network security, you're not going to make software, right? But say you are in a CISO position or you are in a senior position and the company is buying some software or company is making some software. That is where your advisory capacity can kick in, and you can actually bring in a lot of value in secrecy by design or privacy by design. Suppose you are making a software which deals with PII or PHI. Okay, you'll be surprised. You think that everyone knows everything. So immediately after I came out of army, I was working with a very well-known, very well-funded uh, organization based out of Switzerland. They were funded by a very big company, okay, CQG, uh, close to funding of around $12 million, valuation of around 75 million. So I go on a call with them as a consulting CISO. They take me as a consulting CISO. And the first thing I asked them was, okay, so you are under the purview of GDPR, and all the high-fi finance guys knew nothing about GDPR. So the CEO was an Indian guy, Ravi. So I said, Ravi, you are the head of Forex business for UBS for like 20 years, and you don't know what's GDPR. So, yeah, it's something to do with something. Yeah, it's something to do. That was his reply. I said, look, it's a privacy based tool because you will be collecting a lot of PII, and so there's a requirement to meet the GDPR conditions. So you might think that people know everything, but you'll be surprised that people know nothing. Okay, so that is a business risk which can come in as far as software development security matters are concerned. Today in India, at least, there is Digital Privacy Data Act coming in. So you need to understand the software part of it, how you deal with encryption, how you deal with data storage, how you take inputs from the user, how you process them, how do you handle PII and PHI? Because ultimately, software is the one which is doing everything for you, whatever information security policies you want to implement, right? And that's why you should understand broad software development security aspects. Now, why software development security is under the purview of InfoSec professionals is because today everything runs on software, and software development is intensely complex and challenging. Okay, for last 30 years, softwares have been built in a different manners, multiple languages, and everything runs on software today on the internet, right? So it poses a lot of risks to your organizational enterprise security, right? So understanding those risks is very, very important so that you can take appropriate actions as and when they happen in your enterprise environment, right? So once you look at developing systems, software becomes part of it. And that's why the entire process is called System Development Lifecycle, SDLC. So a lot of people say, are you aware of SDLC? They will say, yeah, Software Development Lifecycle. It's actually System Development Lifecycle. Okay. Now, software forms part of the system. It's not that software is out of the system. Software is part of the system. So that's why when you build system, whether it's hardware or software, it follows the control methodology for entire life cycle. Okay. So what is software development security? So what happens? How do you get software in your environment? You can either, there was an era when you used to make software for everything. Okay, you wanted to make a ERP system, you would hire a software company, make an ERP for yourself. Okay, or you will take a standardized software and customize it for yourself. Okay, or you have well-known softwares available which you will directly pick it from the market and use it, right? But there are a lot of threats associated with the software because software when initially when made, there were no standardization. Okay, they might have a lot of vulnerabilities. What is the maturity of the person or the people or the company which is developing the software? Do they understand software development security? You want to build a software quickly, you go to some small software company, you buy it, and it suddenly becomes a hit, and people start adopting, and finally you come to know there are huge vulnerabilities in the system. So that should not happen, and that's why trust and assurance is a major critical issue once you are procuring software from third parties. Okay. So that's why software is important. And there are a multitude of threats in software, and you have to deal with those threats. Okay. Got a small question, and then let's move ahead.
I have a question.
Yeah, Manish.
Like while buying a software or a hardware or a system, what is that specification we should look, I mean, from the vendor or the seller, so that that can guarantee us that, okay, this has been taken care while development itself, the security.
You remember EL?
Ah, yes. Yes. Okay.
So a good software company will always go for a EL, SSA 18 evaluation. Okay. It will always go for SSA 18 evaluation. It will try to get a EL 1, 2, 3, 4. At least minimum EL 4 is desired. EL 4 is strict. EL 3 is at least desired. At least.
So each system development, and we can look for it, like even in OT, I'm just trying to.
Yes. Any system you can look for standardization SSA 18 standard. It's a very, very industry specific standardization. Okay. SSA 18 deals with everything. So like in India, at least SQTC, there's an organization by BIS, Bharat Institute of Standards. It has a lab in Calcutta called Standardization and Quality Testing Committee. Standardization and Quality, yeah, SQTC. They do up to EAL3. So all software systems used in critical, systems have to undergo EAL3 and by SQTC. If you look at even Windows development, you will find it's EAL4 if I'm not wrong. Windows, Mac OS, they are all EAL4. So you can look for EAL levels. Okay. You remember, right? The protection profile, security target, EAL 1 to 7 are there. For rocket systems, it's supposed to be EAL7. For flight control systems, it's supposed to be EAL7. Means no error is acceptable. Okay.
Okay.
Right. So you all have guessed it correctly. Yeah, input validation, because software accept a lot of inputs from external agencies. That validation and output encoding has to be checked. Okay. So how is software developed, right? Software is development based on a problem statement. There is a problem statement which you need to, take from manual workload to a computational workload, and you have to plan software development properly. Even if you want to buy commercially off the shelf software, you have to plan it, because there will be so many vendors and so many software types which will be available. What to buy, what to take, right? Whatever decision you take, whether to build a software or whether to buy a software, security design implementation should be there right from the start. Security cannot come on later. Okay, that is the requirement. So once you develop softwares are developed using certain languages. Why? Because computer systems do not understand human interpreted language, right? So you need some kind of a layer between the computer and the human beings to convert what you want to tell the computer into what it understands, right? So what happens is humans are very, very bad at what computers interpret. Now, computers only interpret binaries, right? They can only process binaries. So now, how do human beings interact with and convert this language? So what happens is humans write programs in human readable language. Okay? That print, if, then. So human beings write in a human interpreted language. Such languages are called high-level languages. High-level languages are the intermediate languages between you and the computer system. What high-level languages help you is write code in a simplistic manner using English, okay, or any other natural language. Okay? Now, but computers don't understand high-level language. So what happens is high-level language has to become, converted into binaries. And this binary conversion is done either by a compiler or a interpreter. Because this is what will go inside the CPU. And CPU will understand this particular language only, that is 0 or 1. Right? So that's why these are the 4 things which you should be aware of for CISSP exam. What are the common HLL languages, high-level languages? C, C++, Python, Ruby, Go. Okay. For what else? JavaScript. These are all high-level
COBOL,
languages.
Python, yeah, all
COBOL,
programming
Python.
language. Yes.
All programming languages are high-level language. What is a compiler and an interpreter? Okay, so if you are writing code, what happens is you write millions of lines of code, right? Now, compilers, what they do, they compile. Compile means they take the complete code, convert it into one binary. Okay, and then give it to the system. Whereas an interpreter picks up your line by line. That means whatever you write, it immediately interprets. It does it line by line. Some kind of a real-time interpretation of what is the code you are writing. That is the only difference. Okay. Whenever there is a dynamic environment, there is a change on the code is dynamic, interpreters are used. Whereas the change in the code is not dynamic, it is static, compilers are used. Okay. Now, when you write code, what happens is many times what happens, you write a piece of code and then you need to reuse the code in some other project. You wrote a code for login sequence. Okay, what will be a login sequence? Now it's stored in some kind of a repository somewhere, and you want to reuse it. Okay, so codes can be reused in other projects. Very common, right? You can also make this code and push it to some public library on GitHub. Say GitHub, you put it on a public library. Why? Because you wrote a nice, beautiful piece of code and you thought that everybody should use it. You put it in public library. Tomorrow I said, hey, this is a beautiful login sequence. Let me download and use it. What you did, you bugged it. You bugged it with a backdoor. Okay, and that backdoor I have incorporated now in my project. So you should be very careful when developers are reusing code and public library. Okay, and that's why a good way of managing software is by using code repositories. It is very important that you have your own code repository. So what is a code repository? Anyone? Like GitHub is a public code repository. Okay, GitHub is a public code repository. You can just buy your own space and you can have a small private code repo inside a public repository. Basically, a place where you can store your code. Otherwise, erstwhile, developers used to store code on their machines. So there is a chance that you wrote some proprietary code and that code gets diverged from your machine to the outside world. Okay, that's why organizations use code repositories. Now, all the cloud environments like AWS, Azure, and GCP also provide you code repositories, where you can push your code and keep your code there. What happens in a code repository is a code repository is an empty space. You first time write a code, okay, this becomes the master code. And then whenever people pull the code from here, they let you pull and they keep a record that you pulled the code. Then you make some changes in it. And the moment you push it, what happens is a branch is created. Okay. And similarly, as many times you push, branches keep getting created on top of each other. And finally, when the code is done, you merge all the code and produce a single product in the end. Okay. That helps you in finding what you did with the code every time you pulled the code from the master repository. Clear? The concept of repository? Okay. So that's why use a repository is a good way, because then you can have access control built upon your repositories, because then you can give some identity and some kind of an access control to your developers who are using the repository. It will help you in versioning the code. Okay. Every time there are changes made in the code, you'll be able to version it. Auto versioning is enabled. Okay. And then developers use something called SDK and IDE. Okay. SDK is software development kit. IDE is integrated development environment. Okay. What is an SDK and what is an IDE? Okay. I made a software. I made a software. It does KYC for users. Okay. Now I need to give you documentation. Okay. All developers want to use this software for doing KYC. I build a software development kit. This software development kit allows you to write your own code, which will be interacting with this backend software of mine. I make a software development kit for using my software so that you can incorporate it in your software. I give you a small kit. You use that kit to interact with the master software which I have built. Okay, that's called a SDK. Okay, and then there is an integrated development environment, IDE. What is IDE? IDE is nothing but a piece of software where you can use multiple languages. You can use Python, you can use HTML, you can use Go, you can use Ruby. It's basically a standardized platform where people can write code. Okay, like Visual Studio. Okay, this is the integrated development environment given by Microsoft for free. Right? People use it as the most prominent IDE used by the developers. Now, if there are any vulnerabilities in these SDKs and IDEs, you might incorporate those vulnerabilities in your code. Okay, your code might become vulnerable to the vulnerabilities which are inbuilt in the development platform itself. Okay, so that's why the SDs and IDs should be properly patched at all times. Okay, one question and then we'll go ahead. Right. So you all got it correct. So these are the 4 things which you have to keep in mind. 3 things which you have to keep in mind whenever questions regarding SDK and IDEs come in. Right. Now, once programmers started programming, there are different kinds of programming techniques. Okay. One is called linear programming, one is called object-oriented programming, and one is called functional programming. Okay. Now, what is linear? What is object-oriented? Linear programming is, okay, you have input. Okay, you take this input, do something, and give output. Okay, that means x is equal to 2, y is equal to 3, print x plus y, you get answer 5. Every time you change the input, you get output, fixed output, right? This is linear programming. Okay. Then what you do in object-oriented programming is you have one linear component, you have second linear component, you have third linear component, you club them. Okay. These components generally are to be imbibed in most of the code. So what happens is this becomes kind of a library for you. Okay. And now you start doing object-oriented programming. Now, what is the object? This is sum. This is division. This is multiplication. And this is, say, subtraction. Okay. These are the 4 properties of your, this is your parent function. Okay. Parent object. This is a parent object, right? Now, what happens once you proceed in the code? If you have certain requirement of doing addition, you just write sum. Once you write sum, the programming language understands that it has to go fetch the object and carry out that mathematical calculation. Okay, it can be mathematical calculation, it could be anything, but you have defined that object. You have defined the object. Okay. Now, whenever in the code you need that object, you just mention that sum, whatever you need to do with whichever components, you tell that to the software, to the IDE where you are writing. It knows that it has to go and fetch it from the parent object library. That's called object-oriented programming. So what happens is you don't repeat every time. Commonly, most common functions you don't have to repeat every time. You don't have to write. You just have to call them from your. You have to inherit them from your master code. That's called object-oriented programming. And then there is something called functional programming. Functional programming is you basically, you have a lot of parameters in your code, parameter 1, parameter 2, parameter 3, and you create a small code, which is a functional code, does a particular task, right? And these functional codes can be reused by anyone. Okay. So say if this functional code carries out an LCM, right? I build an API on top of it. Every time I have to write a code, I now interact with this program and tell, hey, can you carry out LCM of these 10 numbers and give me the result? It gives me the LCM of these 10 numbers. Okay, so this is called functional programming. What is the difference between functional and object-oriented? Functional programming, functional code is outside your main code. In object-oriented, the libraries from where you recall your functions are there within the code. They are in the code. Okay, whereas here, it's outside, you can interact with it and get the result. That's called functional programming. Most of the programming done today is functional on the cloud. On the cloud, you have mainly functional program. Object-oriented program are software which you develop yourself, which are a closed-loop software. It can do anything on your own, like this PowerPoint. It's object-oriented programming because it doesn't require any external help. If there is no internet, nothing, it will work. Why? Because it is dependent on libraries which are inbuilt inside. Okay. Whereas if you go on UIDAI portal and want to do a KYC, unless there is an internet, you cannot do. Why? Because it interacts with some backend with some kind of a functional program. Okay. Now, you were asking, right, Manish, that how do I know what kind of techniques you have, used to buy? How do I differentiate what is your level of, assurance that you have in software, right?
Yes,
So you
yes.
had asked it prematurely, and that's what software development. You have to match the common criteria requirements for software. So if your software is meeting the common criteria requirements, you can yourself lay out that your software should be EAL1 or EAL3. But there are still certain software development, software assurance models, which we will be telling. Okay. Some most common software development security issues which you need to understand is, since software deals with user input, you always have to carry out input validation. What is input validation? I need to give username and password. I give you SQL query strings. That will be a input injection or SQL injection. So I need to check whether whatever user is giving, is it right? Will my program accept it? Okay. If not, then what will happen is hackers or anybody will be able to inject code which may lead to a malfunction or unintended data disclosure. Okay. Authentication management. Your software should be able to authenticate who is trying to access your backend. Okay. Who is there? So always that IEEE thing should be there in all software. Then session management. Once the session is created, the session should not be taken over by someone else. Okay, so session management is also important. Once a session is idle, it should drop out the connection. And finally, whatever actions you do on your software, it has to be logged. Okay, so that tomorrow, if there's some fault or some kind of activity, you are able to go and check the logs and see what happened on your software. Okay. The software is designed, whenever you design software, they are designed for either fail secure or fail open. Now, fail secure systems means once they are failing, they go into a secure mode. Why? Because what is important? The integrity of the software is important. Integrity of the data is important. If the integrity of the data is important and your system is failing, your system should go into fail secure mode. But if a system is failing and availability is more important, then a system should fail open, right? That is the concept of fail secure and fail open. So if there is a threat to life, threat to availability, systems are generally designed for fail open. If there is a requirement to safeguard something, systems are designed to fail secure. Okay. Software should be versioned and they should be released with versioning. Whenever there is a new patch or something released, the versioning is done. Software is generally licensed under open licensing schemes or closed licensing scheme. Open licensing scheme are called GNU license, okay, Apache license, and closed licensing scheme are copyrighted. Basically, you copyright your software, and then you provide deployment and support to your client whenever software is being utilized by your customer. Okay. A question to understand failsafe. That would be fail open, Manish, isn't it?
Yes, yes. I'm so sorry. It's B.
Yes, this is fail open. A
Yes.
system report reverts to previous known stable state. It's
Yes.
not it's fail secure. Okay,
Yes.
this is fail secure.
This is OT jumping all the time in my mind.
Yeah, this is fail safe. Why? Because you're saving the system, right?
Yes, yes.
And this is probably a kind of, this is no state.
Yes.
Right? Okay, good. So that's why once you look at software, software goes through a life cycle. You have some requirement, then you debate that requirement, you form certain kind of objectives, what your software does, then you find out who can build the software for you. Okay, then you, once the software is developed, you do a design review, and then you put the software to use it, and keep on maintaining it till such time it is discarded. So software and systems are developed using generally this particular sequencing. So first thing you have is a conceptual definition, where you know that you need to build something, right? From there, first thing you make a documentation is called functional requirement gathering or functional requirement definition. What is this software supposed to do? You tell it functionally, my software should be able to do X, Y, Z. Okay. Then you also incorporate security at this point. And whatever security requirements are there, you specify those security control right away. Okay, you do not wait for the software to be built. Once this has been done, once the software has been built, then you do a design. Once the software, all this is done, you do a design review that whether you have given a correct specification or not. Then once the specifications have been defined, the developers start coding your requirements. Okay. Once the coding is being done, developers do something called a structured walkthrough. They keep on walking through the code to see whether the code is being developed properly. So once all the coding is done, then the coding is tested, code is tested, integrated, and seen that it is working. And then it is deployed and it is maintained throughout its life cycle. Okay. So that is the sequence of software development or system development life cycle.